Hello everyone, I'm Megha. The presentation deals with 5G mobile technology. Let's see what all it includes.
5G mobile technology. 5G technology stands for fifth generation mobile technology. 5G denote the next major phase of mobile telecommunication standards beyond the upcoming 4G standards. From generation 1G to 2.5G and from 3G to 5G, this world of telecommunication has seen a number of improvements along with improved performance with every passing day. This fast revolution in mobile computing changes our day-to-day life, that is the way we work, interact, learn, etc. Currently, 5G term is not officially used. In fifth generation, researchers are being made on development of worldwide wireless web, dynamic ad hoc, wireless networks, and real wireless world. 5G technology will change the way most high bandwidth users access their phones. With 5G pushed over a VoIP enabled device, people will experience a level of call volume and data transmission never experienced before. 5G technology is offering the service in product engineering, documentation, support in electronics transaction, etc. As a customer become more and more aware of the mobile phone telecom technology, he or she will look for a decent package altogether, including all the advanced features a cell phone can have. Hence, the search for new technology always the main motive of leading cell phone giants to out-innovate their competitors. The goal of a 5G based communication network would ideally answer the challenges that a 4G would present once it has entered widespread use. In the next few minutes, we are going to cover evolution from 1G to 5G networks, and next is 5G mobile technology, advantages of 5G technology, architectures of 5G technology, design of 5G mobile network architecture, and the comparison from 1G to 5G technology. So we'll see the evolution from 1G to 5G networks, how it went on till 5G. Cell phones are used millions and billions of users worldwide. How many of us know the technology behind cell phones that is used for our communication? I have also interviewed about the type of the technology used in my phone. What are these 1G, 2G, 3G and 4G technologies? Here in all these, G stands for generation. These 1G, 2G, 3G and 4G are the generations of wireless telecom connectivity. In 1945, the zero generation of the mobile telephones was introduced. Mobile telephone service were not officially categorized as mobile phones since they did not support the automatic change of channel frequency during calls. 1G, time division multiple access and frequency division multiple access, was the initial wireless telecom network system. It's outdated now. The analog brick phones and back phones are under 1G technology. Cell phones era began with 1G. The next era, 2G, has taken its place of 1G. Cell phones received their first major upgrade when they went from 1G to 2G. This leap effective took cell phones from analog to digital. 2G and 2.5G were versions of GSM and CDMA connections, and GSM is still the most popular technology but with no internet. Fortunately, GPRS, an additional service, is provided over GSM for the purpose of internet access. GPRS has been developed and thus eGPRS was created. It's more secure and faster than GPRS. Then 3G came, the new wireless CDMA technology. It is the first wireless telecom technology that provides broadband speed internet connection on mobile phones. It has been specially made for the demand of internet on the smartphones. Further, development led to the creation of 3.5G, which provides blazing fast internet connection on phones up to the speed of 7.2 Mbps. A smartphone can be connected to a PC to share its internet connection, and 3G and 3.5G are ideal for this. But as this WCDMA technology is not available in all the regions, it's not as popular as GSM yet. Before making the major leap from 2G to 3G wireless networks, the lesser known 2.5G was an interim standard that bridged the gap. 4G, which is also known as beyond 3G or fourth generation cell phone technology, refers to entirely new evolution. Developers are now going from 4G, which will provide internet up to the speed of 1 Gbps. It is said to be able to overcome the problems of weak network strength and should provide a much wider network, making sure that the users get higher speed connectivity anytime, anywhere. No doubt 4G will open new doors of revolutionary internet technologies, but for now 3G and 3.5G are the best. 4G will allow for the speeds of up to 100 Mbps. 4G promises voice, data and high quality multimedia in real time from all the time and anywhere. Let's go in detail with all the generations now. First comes 1G mobile technology. First generation wireless technology is the original analog. An analog or analog is any continuous signal for which the time varying feature of the signal is a representation of some other time varying quantity. Voice only cellular telephone standards developed in the 1980s. The main difference between two succeeding mobile telephone systems 1G and 2G is that the radio signals that 1G networks use are analog while 2G networks are digital, although both systems use digital signaling to connect the radio towers. To the rest of the telephone systems, the voice itself during a call is encoded to digital signals in 2G, whereas 1G is only modulated to higher frequency, typically 150 MHz and up. Speed of the first generation of analog cell phones is into 2.4 kbps. 1G, there are a number of standards for 1G. Some of them are NMT Nordic mobile telephones and AMPS advanced mobile phone systems. Mobile technology. 2G is short for second generation wireless telephone technology. Second generation 2G cellular telecom networks were commercially launched on the GSM standard in Finland in 1991. 2G network allows for much greater penetration intensity. 2G technologies enable the various mobile phone networks to provide the services such as text messages, picture messages and MMS. 2G technology is more efficient. 2G technology holds sufficient security for both the sender and the receiver. All text messages are digitally encrypted. This digital encryption allows for transfer of the data in such a way that only the intended receiver can receive and read it. Second generation technologies are either time division multiple access TDMA or code division multiple access CDMA. TDMA allows for the division of signal into time slots. CDMA allocates each user a special code to communicate over a multiplex physical channel. Different TDMA technologies are GSM, PDC, IDEN, etc. Although this technology originates from the Europe, but now it is used in more than 212 countries in the world. GSM technology helps to establish international roamings also. Speeds up to 64 kbps. They are actually the data transfer speeds. Now we'll go to 3G mobile technology. It is the International Mobile Telecommunications 2000. It's better known as 3G or third generation. It is a generation of the standards for mobile phones and mobile telecommunication services, fulfilling specifications by the International Telecommunication Union. The use of 3G technology is also able to transmit packet switching data efficiently at better and increased bandwidth. 3G mobile technology offers more advanced services to mobile users. The spectral efficiency of 3G technology is better than 2G technologies. Spectral efficiency is the measurement of the rate of the information transfer over any communication system. 3G is also known as 1IMT 2000. Transmission speeds, some of the features of 3G are transmission speeds are from 125 kbps to 2 mbps. In 2005, 3G is ready to live up to its performance in computer networks. Data are sent through technology called packet switching. Voice calls are interpreted using circuit switching, access to global roaming, clarity in voice calls, etc. Now we will see the present running technology, 4G mobile technology. 4G refers to the fourth generation of the cellular wireless standards. It is a successor to 3G and 2G families of standards. The nomenclature of the generations generally refers to a change in the fundamental nature of the service, non-backwards compatible transmission technology and new frequency bands. 3G technologies make use of TDMA and CDMA. 3G third generation technologies made use of value added services like mobile television, GPS and video conferencing. The basic feature of 3G technology is fast data transfer rate. "4G should be able to provide very smooth global roaming and 4G mobile phones. With 4G mobile phones, it offers both cellular and broadband multimedia services everywhere. Like mobile TV, a provider redirects a TV channel directly to the subscriber phones where it can be watched. Video on demand, a provider sends a movie to the subscriber's phone. Video conferencing, subscribers can see as well as talk to each other. Telemedicine, a medical provider monitors or provides advice to potentially isolated subscribers. It's of more use now. Mobile ultra broadband, gigabit speed access and multiple carrier transmission. Now the new feature, what our concept mainly deals with is 5G mobile technology. Now what is this 5G and what it offers? 5G technology stands for 5th generation mobile technology, as I already said. 5G technology has changed the means to use cell phones within very high bandwidth. User never experienced ever before such a high value technology. The 5G technology includes all type of advanced features which makes 5G technology most powerful and in huge demand in near future. The gigantic array of innovative technology being built into new cell phones is stunning. 5G technologies which are on hand held phones offering more power and features than at least 1000 lunar modules. A user can also hook their 5G technology cell phones with their laptop to get broadband internet access. 5G technology including camera, MP3 recording, video player, large phone memory, dialing speed, audio player and much more you never imagined. For children, rocking fun Bluetooth technology and PicoNets may become in market. Some of the offers, what are the features that are 5G offers, what are the advantages that the 5G technology provides is advanced billing interfaces of 5G technology makes it more attractive and effective. If you can be able to pay all your bills in the single payment with your mobile, if you can able to send tsunami or earthquake before it occurs, and it would be good if you can able to visualize lively all planets and universe. We can lock our laptop, car, bike using our mobile phones, etc. These are some of the exciting features of the 5G. 5G technology is providing large broadcasting of data in gigabit with supporting almost 65,000 connections. 5G technology offers transporter class gateway with unparalleled consistency. Through remote management offered by 5G technology, a user can get better and fast solution. The 5G is now capable of supporting wireless World Wide Web (WWW). Now we'll see the main architecture, what leads to 5G. The 5G are basic architecture of 5G technologies. Uh, 5G architectures are mainly ubiquitous computing. 5G would be about ubiquitous computing. That is, having the ability to access the applications want from any platform, anywhere, anytime. To create such an environment, one needs to integrate various applications emerging from various engineering practices. Human life will be surrounded by intelligent sensors which will bring radical change to human life's daily approaches of doing things as. Your intelligent car will send you SMS to your cell phones from your car. Your home security camera is attached to secured internet so that you can view your sitting room on your laptop, mobile phone screen by accessing secure website. You are receiving regular MMS from your hospital about your medication need and next doctor appointment. 5G actually deals with some IP concept that's called as flatter IP concept. Let's see what is it. At regular intervals, semiconductor manufacturers advance to a new generation with smaller feature sizes. This allows them to incorporate more functions into a given area of the silicon and hence more features or new capabilities into electronic devices like cell phones. Increased processing capacity will be allow mobile devices to do more tasks than before. This will lead to even the flatter IP network, as flat IP has shifted some of the BSC or RNSC radio resource functions to base stations. Flatter IP will shift some of the RR functions to mobile devices from base stations. Finally, your cell phone will not be just access device, but it will also perform some of the radio resource management functions. With a shift to flat IP architectures, mobile operators can reduce the number of network elements in the data path to lower operation cost and capital expenditure, partially decouple the cost of the delivering service from the volume of the data transmitted to align infrastructure capabilities with emerging application requirements, minimize system latency and enable applications with a lower tolerance for delay. Upcoming latency enhancement on the radio link can also be fully realized. Evolve radio access and packet port networks independently of each other to a great extent than in the past, creating greater flexibility in network planning and deployment. Create a platform that will enable mobile broadband operators to be competitive from a price or a performance perspective with wired networks. All these concepts now. Let's see the design. This is how the design of the 5G somewhat looks like. This figure shows the network architecture for 5G, which is all IP based model for wireless and mobile network interoperability. The system uses a terminal and number of the independent access technology. Let's have a look of it now. Here only one terminal we have and a number of independent access technologies. Each of the radio access technologies seen as the IP link to the outside internet world. There should be different radio interface for each radio access technology in the mobile terminal. 5G architecture nanocore. What is this nanocore? Sophisticated technology has enabled an age of globalization. Technological convergence is the tendency for different technological systems to evolve towards performance similar tasks. What Nicholas Negropolit labeled the transformation of atoms to bits, the digitalization of all media content. When words, images and sounds are transformed into digital information, it expands the potential relationship between them and enable them to flow access platforms. The 5G nanocore is a convergence of below mentioned technologies. These technologies have their own impact on exciting wireless network, which makes them into 5G. The nanotechnology, cloud computing and all IP platforms. Let's go in detail of these technologies. First one comes as nanotechnology. Nanotechnology is the application of the nanoscience to control process on nanometer scale, that is between 0.1 and 100 nm. The field is also known as molecular nanotechnology, MNT. MNT deals with control of the structure of the matter based on atom by atom and molecule by molecule engineering. The term nanotechnology was introduced by Nori Taniguchi in 1974 at the Tokyo International Conference on Production Engineering. Nanotechnology is the next industrial revolution and the telecommunication industry will be radically transformed by it in a few years. Nanotechnology has shown its impact on both mobile as well as the core network. Apart from this, it has its own impact on the sensors as well as security. This is considered as a most significant in telecommunication. We will be discussing the same in our further slides. When we come across the concept called as nano equipment, what is this nano equipment? We'll see now. Mobile phone has become more than a communication device in the modern world. It has turned into an identity of an individual. In 5G nanocore, these mobile are referred as nano equipment as they are geared up with nanotechnology. One of the central visions of the wireless industry aims at ambient tech intelligence. Computation and communication always available and ready to serve the user in an intelligent way. This requires that the devices are mobile. Mobile devices together with the intelligence that will be enabled in human environments. Home, offices, public places will create a new platform that enables ubiquitous sensing, computing and communication. Some of the specifications of the nano equipment are as follows. Self-cleaning. It should be a cleaning, not canning. The phone cleans by itself. Self-powered. The phone derives its energy or power from the sun, water or air. It sends the environment. The phone will tell you the weather, the amount of air pollution present, etc. And then it's flexible, you can bend but not break. Transparent, see through your phones. The second concept which comes under nanocore is cloud computing. You might be aware of it. Cloud computing is a technology that uses the internet and central remote server to maintain data and applications. In 5G network, this central remote server will be our content provider. Cloud computing allows consumers and business to use applications without installation and access their personal files at any computer with internet access. The same concept is going to be used in the nanocore, where the user tries to access his private account from a global content provider through nanocore in form of a cloud. The development of the cloud computing provides operators with tremendous opportunities. Since cloud computing relies on the networks, it shows the significance of networks and promotes network development. It also requires secure and reliable service providers capabilities that operators have deep expertise in. Operators can enter the cloud computing market and create new value-added services and experience by integrating industry, content and application in the digital supermarket model. This could make our user to obtain much more real-time application to utilize his 5G network efficiently. Cloud computing customers avoid capital expenditure for the nanocore, thereby also reducing the cost of purchasing physical infrastructure by renting the usage from a third-party provider. The nanocore diverts the resources and pay for what it uses. There are some of the segments of the cloud computing. Cloud computing has three main segments which are as follows. Application, it is based on demand software services. On-demand software services come in different varieties. They vary in their pricing scheme and how the software is delivered to end users. In the past, the end users would purchase a server that can be accessed by end user. Platform. The platform segment of the cloud computing refers to products that are used to deploy internet. NetSuite, Amazon, Google and Microsoft have also developed platforms that allow users to access applications from centralized servers. Infrastructure. The third segment in the cloud computing, known as infrastructure, is the backbone of the entire concept. Infrastructure vendors environments such as Google Gears allow users to build applications. Cloud storage such as Amazon's S3 is also considered to be a part of the infrastructure segment. 5G nanocore will efficiently utilizes all the above 3G segments to satisfy his customer demands. The concept of the cloud computing will reduce the capex of the 5G network deployment. In turn, this will create a less billing to the end users for all kinds of the services that he utilizes through nanocore. The third concept under the nanocore is all IP network. As already discussed for converging different technologies to form a single 5G nanocore, we require a common platform to interact. Flat IP architecture act as an essential part of the 5G network. The all IP network is an evolution of the 3GPP system to meet the increasing demands of the mobile telecommunication market. To meet customer demand for real-time data applications delivered over mobile broadband networks, wireless operators are turning to flat IP network architectures, primarily focused upon enhancement of the packet switch technologies. The key benefits of the flat IP architectures are as follows: lower cost, universal seamless access, improved user experience, reduced system latency, decoupled radio access, and core network evolution. To drive all IP-based services in placing stringent performance demands on IP-based equipment and devices, which in turn is growing demand for multi-core technology. There is a strong growing demand for advanced telecommunication services on wired and wireless next. Some of the applications, what are the features provided by 5G mobile technology? We'll rewind it once. Our mobile can share the workload, and if you can able to sense tsunami or earthquake before it occurs, mobile phone gets cleaned by its own, and you can able to fold your mobile as per your desire. And then you can be able to identify a stolen mobile with nanoseconds. Mobile can able to suggest you possible medicine as per your healthiness. This is the comparison of the various mobile technologies which we had. Let's see the conclusion part. We are at the end of the 5G technology conclusion. Let's see the conclusion part of the 5G. The development of the mobile and the wireless networks is going towards higher data rates and all IP principle. Currently, there are many available radio access technologies which provide possibility for IP-based communication on the network layer, as well as there is migration of all the services in IP environments, including the traditional telephony and even television, besides the traditional internet services such as web and electronic mail as most used among the others. On the other side, mobile terminals are obtaining each year more processing power, more memory or broad and longer battery life for the same application. It is expected that the initial internet philosophy of keeping the network simple as possible and giving more functionalities to the end nodes will become reality in the future generation of mobile networks, here referred to as 5G. The proposed architecture for future 5G networks can be implemented using components of the shelf, existing and standardized internet technologies, and its implementation is transparent to the radio access technologies, which makes it very likable solutions for the next generation mobile and wireless networks. So that's all about the 5G network mobile technology. Thank you.